Okay, it's chemistry time. don't laugh. Please, this is all I've got. Okay, so we're gonna start with some bell work. I hope you can see the whole screen here. I hope I can press the pin button like I wanted to. It is working, but it's in black. Come on, where are the colors? Oh, here we go. White. Good. Okay, it says calculate the frequency of light with a wavelength of 91.6 millimeters. Remember to first convert to millimeters. So, undo. Oh, golly. Okay, so first we need to convert 96. I was trying to move that thing out of the way. I actually want it smaller after all. That's so cute. Okay, so you should have done this in your bell work. What's the first thing you do, Jasmine?
Manipulate your equation.
Convert.
Right?
Convert. Yeah, we have to convert to 91 from 91.6 millimeters to what meters should this be in?
Meters.
So millimeters to meters. Tell me what conversion factor I ought to use for this haste.
I should have said it out loud.
1,000 what? Well, which
Millimeters?
1,000 millimeters in 1 meter. Answer?
0.0916 meters.
0.0916 meters. Good. Now that I have converted, Jasmine, what should I do next? First, I need to write the equation, right? So what's the equation I should write?
C equals lambda times nu.
Thank you. Now I manipulate. And what am I trying to find from this equation? Frequency. Good. So how do I manipulate this equation to find frequency? First of all, what do each of these things mean? What's C, Natalie? What's C?
Give me a minute.
It's like the word before. What's C, viewers?
Speed of light in a
It's the speed of light in a vacuum, which is measured in the units.
meters per second.
Good. So, and what's the lambda?
It's wavelength.
Wavelength. And the nu?
Frequency.
Good. So how do I manipulate this to find frequency, which is the variable I want to find? Divide lambda on both sides, giving us C lambda equals nu. Right?
Yes.
Now, the next step, of course, Hayes, is
Yeah, you substitute.
I substitute. Tell me what to write.
So then you put 3 times 10 to the 8th
3.00 times 10 to the 8th what?
milliseconds. No, meters per second.
Thank you.
Over 0.096.
0.0916 what?
Meters.
Meters. Good. This will be my answer in. Look here. The meters are going to cancel out, tempting us to say the answer will be in seconds, but seconds is still in. Still in the denominator, so we end up with our answer 1 over second, which is equal to hertz. And the answer numerically is what?
3.275 times 10 to the 10.
Times 10 to the 10. This, I am aware, is probably mostly illegible. You guys can do this kind of, right? I mean, it makes, especially when I say the words out loud, it makes sense. Clear annotations. Let's do the next one. Okay? Number 2, what type of light is that from number 1? So here, I've got this thing up. Let's actually go back to this. I pulled up electromagnetic spectrum. So where did our answer was what?
Microwave.
Okay.
10 to the 10.
Yep. Our answer was in the 10 to the 10th range, which is here.
Microwave.
Yep, this is how you point. Just drag it around. It's in this range, and so it's in the microwave range. Perfect. Okay, back to our whatever it is. Calculate the energy of a photon of the light in number 1. So now what do I do?
So Aisha did this one.
You do the E equals H nu.
Remind me what each of these variables is. E is
Energy.
energy. H is Planck's constant, right? Which is a constant.
And then nu.
And then nu is frequency again. So, am I trying to find energy for this one?
Yes.
Manipulation required?
No.
Good. What should I substitute in, Jasmine?
Ooh, can I tell you?
6.626
So E equals 6.626.
times 10 to the negative 34.
Good. Unit?
Joules times second.
I think
Yeah, that's right.
And then
That's
times
bigger.
it.
gonna say, I think.
Oh, wait, just kidding, lied. Scratch that,
Okay.
erase it. You can't, it's not like your whiteboard.
Look, you can go back. No, you can go back.
Skip.
It's okay. I erased the whole thing, and I didn't really mean to, but
Why'd you put T up there?
this is supposed to be the letter.
Oh.
Thanks for making me feel bad. Times 10 to the negative 34th joule seconds times, sorry,
3.275.
Thank you. I feel like I'm hitting this thing really hard. All right, and the answer here?
2.170 times 10 to the negative 23rd.
A lot of energy or a little energy?
Just kidding.
Little.
No,
Let's all agree.
It's all a lot.
Look at the number again. 2.170 times 10 to the negative 23rd joules. A little, right? Because if we wanted to rewrite this,
Means you go to
exactly, we would write this as 0.22 zeros to 170, right? So it's very, very, very small. Once again, the question was, how much energy does this photon of light have? It's a little tiny bit, right? A photon is a little tiny thing, so it has a little tiny bit of energy. Number 4. You all ready to move on?
Sorry for the tightly.
Are you ready to move on? Goodness gracious. Calculate the energy of a quantum of light having a frequency of 7.88 times 10 to the negative 7 hertz. What should I do first, Stace?
Mr. Kite, we don't have that long left. We have 1 minute.
We gotta move faster. What?
E equals H times 10.
Okay, and then we manipulate?
No.
No.
You substitute. It'd be
6.626, that's the letter 6. Whatever. Go. This is the squiggly
You don't look at it.
times the frequency, which is 7.88. What's the answer? Tell me quick.
5.2216.
5.221 times 10 to the what?
Negative 40.
Negative 40?
Yes.
That's
What?
the math said.
Yeah, but what?
Joules.
Joules.
And it's
What type of
why
light?
was radio?
Oh, radio wave. Radio wave. Okay, thanks for joining us in chemistry.
You can't bite, you can't eat.
I know, I'm still trying to stop it.